Welcome to our Logic semi-annual meeting for June of 2025. Now I'm going to go ahead and introduce our next speaker. I wanted to welcome Pablo Moncada-Larrotiz to our meeting today. He is from MoonDAO and is its co-founder. So Pablo is a notable figure in the field of decentralized technology, especially known for co-founding MoonDAO, a centralized autonomous organization aimed at democratizing space exploration. Before venturing into the realm of DAOs, he worked as a software engineer at Google, where his roles spanned projects at Waymo, YouTube, and other initiatives such as working on exoskeletons for enhancing lower body mobility. He was also a core developer for Constitution DAO, which raised $47 million to purchase an original copy of the U.S. Constitution. This is a super cool story, by the way. I encourage you to look it up from Sotheby's. Pablo's journey also includes time as a biotech startup focusing on engineering human tissues. His educational background includes studies in computer science, mechanical engineering, and business at the University of Michigan. So we are going to hand it off to Pablo, and welcome.
Thanks for the introduction. That was written by ChatGPT. So I'm filling in for Evan. So he's actually giving Adam Savage a tour of Icon, which is like the coolest excuse that I've ever heard to not be able to give a presentation. So Evan actually inspired me. This project came out of the DARPA Luna 10 workshop, where he pitched this idea for Campfire, his vision being that any company can pull up a chair to start contributing to a lunar economy. So I'll read the title here because it's a long one, but I want every single word in that title is important, and I want every word in that title to make sense to people by the end of the presentation. So the title is a trustless transaction and arbitration framework for the enablement of an offline, autonomous, decentralized, off-planet economy. So this is a collaboration between Icon and MoonDAO. Icon builds, they 3D print houses, but they're also working on a ton of technology for the lunar surface to construct landing pads, roadways, non-pressurized structures, and pressurized habitats. I co-founded MoonDAO, which is an open platform to help fund, collaborate, and compete on challenges that get us closer to a lunar settlement. I guess I want to kind of frame the sort of big picture of why are we doing this. So I think a lot of people in this room agree that we need to accelerate a human presence on the moon. Our strength comes from private industry, but that said, private industry, because of the nature of the competition, it becomes difficult to disclose plans with one another, despite this deep interdependence on the harsh environment of the lunar surface. So there's broad agreement on the need for interoperability standards, shared awareness of mission profiles. But the big question is, how do we do this while still guaranteeing a fair playing field? And how can we do this in a way that accelerates collaboration and importantly, de-risks business models so that more private investment can come into the space? So zooming in on some of these problems, there are problems around basically the unclear regulatory environment on the moon. How do we create policies that encourage innovation? We need a better awareness of mission profiles, who will be where, and actually get definite about that. So the interfaces, interoperability standards, geospatial and time-based discrete event simulation, essentially being very concrete about exactly who will be where and at what time and on the surface of the moon, so that companies can very easily collaborate with one another. And why now? So the Luna 10 workshop really was a catalyzing moment for this type of idea. The timing is critical. We have all the ingredients to make this happen, and private industry can really lead the way to help bootstrap a lunar base with better coordination. Evan was able to get an amazing response rate from many of the participants within Luna 10, who agreed that if such a thing were to exist, they would like to be a part of it. So diving in a bit, what does this actually look like? So we have a visualization of the lunar surface, a planning database. Companies can upload their mission profiles. You can scrub the timeline view, see where people are at what time, resource plotter, data streams that are fed in from both public and private sources. And there's already some great starts to this problem, and great resources that are out there, but they don't quite have the ability to, say, upload CAD files or the ability to do federated simulation. So we're really missing a discrete event simulator that can help coordinate many different mission profiles together. That defines resources, the storage or delivery of those resources, and the actual assets that are going to be on the lunar surface that consume or produce those resources. So what would actually be required in order to build something like this? So we have this idea of a visualizer that would be open source, that could be fed in both private and public data. But beyond that, there would be logic to support event simulation. This could include historical and future planning data, as well as real-time transaction data that would actually link this system to the real world. So fleshing this out a little bit more, we have a central database that can feed into the visualizer. There can be mission planning from government, private industry. Logic can help maintain interoperability standards and verify capabilities of missions. And assets can be verified by Logic and other organizations to give reputation to mission profiles. So through kind of diving into this system, Evan pointed out a problem, which is that the system's integrity will be paramount. How can we actually ensure that something like this would be credibly neutral, such that many organizations could rely on this, so they could actually use this in order to build out their own capabilities? They'd really have to trust the system, and it shouldn't be able to give advantage to one company over another. So we actually need to address this at the architecture level to ensure that this system is credibly neutral and secure. So this is where Evan and I joined forces. So my background is in decentralized autonomous organizations. I've dedicated the greater part of the last 4 years to working on this problem. And DAOs today on Earth solve for these problems of security and decentralization, and the blockchain community is already doing this. So blockchain is much more than a currency. You can program in smart contracts. You can actually have organizations that are defined via these smart contracts with programmable organizations that can codify policies and deterministic contracts. You can have governance and incentives that are all done on chain. And these are used in applications where both security and transparency are paramount. And they're actually not just for internet-based applications. There's active research right now in the interface of robotics and smart contracts that allow autonomous systems to transact with one another. And autonomous systems and these agents being code native, they actually operate even better if there aren't humans in the loop, and can transact with one another independently. So, all right, let's actually look at an example, an interaction between two entities within the simulation. So each agent is represented by a wallet that holds a unique private key. This means that only their private key can sign transactions. And we really want to look at the transaction, which is the primitive for an economy. And within a transaction, you really need four things. So you need to be able to know the identity of who you're transacting with. You need to have some standards, the ability to communicate and agree on what is being transacted, accountability. So these are receipts and the financial infrastructure to do payments. And then lastly, arbitration. So confirming that that the services were provided, and then allowing for some dispute resolution. So I'm going to go into each of those four bullet points, starting with identity. And so what we've built out is, or essentially these permissioned SQLite controlled SQLite tables that are controlled by a smart contract. You know, for anyone who works in web today, you know, you'll be very familiar with relational databases. The unique thing about this is that every row is controlled by only that agent, and only they can control a particular row where they could essentially upload information about themselves and their applicable standards, basically register their themselves within a database so that other agents can look them up and understand who they're working with and the standards that they abide by. We call this the SOAR database. This is the Space Object Asset Registry. And you'll also see columns like credentials that can be controlled by logic governance or other consortiums, say, for example, like NASA, that could approve assets and verify that they are abiding by certain standards. So double clicking a bit more on those standards, we actually have a pointer over to another database that we call CIROS. So these are the standards for interoperability and robust operations in space. So these are community maintained standards with various credentialing bodies that can update information about what standards are you know, applied to, say, for example, power or resources, PNT, whatever it is that these agents need in order to collaborate and work together. So this allows for assets to be able to easily find relevant standards and ensure that they can interoperate with the assets that they're adjacent to. So bringing this back to the moon, we actually really want this system to be peer-to-peer and not require internet connectivity. So this architecture also allows for essentially each of these agents to carry a local cache copy of these tables when operating on the lunar surface. So any two agents can find each other on the lunar surface or in simulation, and they can perform a handshake to recognize each other totally offline. They can look up their credentials and verify whether or not they are interoperable with their standards. So essentially, this allows for not just mission planning on Earth, but also ad hoc collaboration and coordination on the lunar surface. So once you determine that you can create this transaction, now each agent can actually pay for resources totally offline and create a local signed copy of the transaction. And again, totally without any internet connection, just purely peer-to-peer. These transactions can be encrypted and then settled on chain. And then once they get back to internet connectivity, they can update their and sync with the Earth-based simulation and update that state. So bringing it all together, what we have is a simulated environment that allows for collaborative mission planning. Agents can register their assets, abide by standards set by relevant organizations. And then once they're on the moon, these agents can transact securely, accessing on-chain databases and financial infrastructure that settles on Earth. So going back to the title, I hope that some of these words are starting to really kind of make sense. We have a trustless, arbitrated, offline, decentralized, and autonomous system for transactions. So we actually made a bit of we had some fun with this. We made a video game to demonstrate the end-to-end flow. So this is meant to essentially help explain what's going on between different agents on the lunar surface. And what you're looking at here is an agent on the bottom right that is collecting regolith, and then an agent on the top, which is also a regolith collector, but is not interoperable with the processing facility in the center. So once the regolith collector goes to the processing facility, they can make a transaction on chain, and perform a handshake in order to verify each other's identity, look up relevant standards, and then create a transaction, which is then reconciled once each of these agents gets internet connectivity. So what's going on here is they're looking up their cached SOAR and Cyrus databases, and then creating this transaction. And you can also accelerate the time within the simulation, so you can essentially start to see hopefully this helps elucidate the concept, and you can imagine eventually hundreds or thousands of these agents coordinating together autonomously, both in simulation and then essentially having the infrastructure such that they can operate on the lunar surface and enable an economy on the lunar surface. Yeah, so let me move here to the next slide. I don't know if I can do that without the video. There we go. So what's next? So phase 2, we aim to integrate more community feedback on what Campfire should become, and we want to open this up to the entire community. We'd like to get more partners engaged with work and help drive the next phase of development. And we have many ideas for next steps, but we really want to work with the Logic community to help make this as useful as possible. If you'd like to get in contact, you can email either me or Evan directly. My email is pablo@moondao.com. Evan's is evanjensen@iconbuild.com. If you scan this QR code, we've created a Discord channel similar to Slack, where we can discuss this idea and talk about next steps. If you're interested in getting involved or you'd like more information, you can jump into the Discord by scanning that QR code. So yeah, thank you very much.
Thanks, Pablo.